So first thing we're going to do is we're going to talk a little bit more about what we just finished talking about. We have a distance time graph, and let's say it has a line like that. What can you tell me about this object?
It's slowly gaining motion. It's moving forward.
It's moving forward. How do you know it's moving forward?
Because the distance is slowly going up.
Because what is positive? The slope is positive. All right? And on a distance time graph, what does the slope tell us?
Velocity.
It tells us the velocity. So slope is the velocity. In this case, the slope is positive, so it's a positive velocity, which means it's moving in a positive direction. Now, is this a constant velocity or a changing velocity?
Constant.
How do you know?
Because the slope is constant.
Slope is constant, so straight line. Straight line means slope is constant, so constant velocity. Okay? So that is kind of the basis of where we're going from here on out. So now let's look at another graph. And it's another distance time graph. Now, let's say it looks like this. What is this object doing?
It's increasing in velocity and speed.
He says it's increasing in velocity.
Accelerating.
He says it's accelerating. How do you know it's accelerating?
Because velocity is increasing as what's the word I'm using for?
Chase, say that again. The slope is not constant. All right? If slope is velocity and my slope is not constant, then my velocity is not constant, which means it must be accelerating. That's the definition of acceleration. Now, is this a positive acceleration or a negative acceleration? How do you know? You would think, but let's talk about how we know for sure. Okay? Let me the reason I say that. If I have a point right here, its slope is the slope of that tangent line, right? And if I have a point right there, the slope is the slope of that tangent line. And if I have a point right here, the slope is the slope of that tangent line. A tangent is a line that touches a curve at only one spot. So when you look at this point right here, I have a positive slope, but it's a shallow slope. And at this point right here, I have a positive slope, but it's steeper. Steeper slope means what?
And it's going faster.
It's going faster. So I started out relatively slow, a little bit faster, so it's speeding up, right? Its velocity is changing in the positive direction, okay? It was positive, now it's more positive, now it's more positive. It's changing in the positive direction, so my acceleration is positive because it's changing in the positive direction. Does that make sense?
All right.
Yes, ma'am.
Didn't we just write down that acceleration was something in time, not distance in time? I thought that.
Acceleration is a change in velocity. That was on a different graph what we were talking about earlier. Okay? Now, let's look at another graph. Okay? Let's say this one is still a distance time graph, but now the object's doing that. Okay? So, is it still accelerating?
Wait, what? It is at first, but
Is it still accelerating?
yes.
Yes, because is its velocity still changing?
Yes.
Yes. So, let's look at the points again. If I pick a point right here, its slope is like that. If I pick a point right here, its slope is like that. If I pick a point right here, its slope is like that. Okay? So, what is it doing? Does it still have a positive slope?
Yes.
Yes. Does it still have a positive slope?
Yes.
Is it bigger or smaller? It's a smaller slope. It's a less steep line, so it's a smaller slope. So what's this object actually doing? It's slowing down. But is its acceleration positive or negative? The acceleration is negative. All right? Because, again, remember what acceleration is. Acceleration is the change in velocity. My change here is negative because it's positive, and now it's less positive, and now it's less positive. So the velocity is changing negatively.
Oh, okay.
Can it,
I hope so.
are negative ones always concave down and positive ones always concave?
We'll get to that. Okay. You have a question, sir?
So, with this, when you have like the red line with the slope, where are you drawing the slope from? If it's not from like the
It's through this point right here. It's the line through that point.
Okay.
Okay? All right. Now let's look at another one. That was negative acceleration. Let's look at another one. All right. Say it does this. Still accelerating because we still have a curve. Okay? So now, again, let's look at our points. At that point, the slope is like this. At this point, the slope is like that. At this point, the slope is like that. So, is my slope steep here or shallow? Steep. So is it moving fast or slow? It's moving fast. My slope here? It's shallow. So is it moving as fast? No. So it's slowing down, correct? All right. So it's slowing down. So is its acceleration positive or negative?
Negative.
All right. The acceleration is positive, and let's look at why. First off, is my velocity positive or negative? Yeah, the slope is negative, so my velocity is negative, right? But it's less negative. It's less negative. My velocity is negative, but it's changing towards the positive. So I have a positive acceleration because acceleration is change in velocity. So I have a positive change in my velocity because let's say this was negative 5 and this was negative 2. Negative 5 is less or more negative than negative 2, so I have to add 3 to negative 5 to get to negative 2, right? So a plus 3 means I'm positive change. Okay? So acceleration is positive because I have a positive change. One more. Okay? We have, again, a distance time. This time we're going to do that. Now, is it speeding up or slowing down?
It's speeding up and it's negative.
It's speeding up. Let's see if that's right. Right here, we have a slope like that. Right here, we have a slope like that. Right here, we have a slope like that. So my slope is getting steeper, so it is speeding up. Now, is my slope positive or negative? Negative. So, is it becoming more negative or less negative? It's becoming more negative, so my acceleration is negative. If I'm at negative 5, how do I get to negative 7? I subtract. I change negatively. So if I want to become more negative, I have to have a negative change. And acceleration is the change in velocity. So if I have a negative change, it's a negative acceleration. Okay? So now let's look at all four of these together. As Grant hit on a second ago, we're going to talk about that relationship. Okay? So we have 4 different graphs. I'll number them 1, 2, 3, and 4. Which of these graphs were speeding up? Well, sorry, let me get back to that. Which of these graphs are positive acceleration? Well, this one's positive and this one's positive. All right? And it's curving up and this one's curving up, meaning that it is facing up. The curve faces up. Okay? This one is a negative acceleration and this one's a negative acceleration, and their curve is facing down. So the way I like to look at this is smiley faces are positive, frowny faces are negative. So if your graph makes a smiley face or any portion of a smiley face, it is a positive acceleration. If your graph makes a frowny face or any portion of a frowny face, it is a negative acceleration. Or to use the mathematical terms that Grant used earlier, concave up or concave down. Okay? I like smiles and frowns. All right? Like the emoticons of physics right here. So, now, which of these are speeding up? 1, 2, 3, or 4?
They're all, no.
One, two, and 4.
2 and 4.
Say 2 and 4 are speeding up. But,
That's the.
It's either 2 and 4 or 1 and 3, either or.
No, it's 1.
you might be right. All right, let's look at each one individually. First off, let's look at number 1 first. Is the velocity positive or negative? The velocity is positive because the slope is positive. Is my acceleration positive or negative? My acceleration is positive. It's concave up. All right? So graph 2. Is the velocity positive or negative?
Negative.
The velocity is positive because the slope is still positive. Is the acceleration positive or negative?
That's negative.
The acceleration is negative because it's concave down. All right? So, on this one, velocity positive or negative?
Negative.
Velocity is negative because the slope is negative at all points. But it's smiley face, so
It's positive.
acceleration is positive. All right? Now, number 4, velocity is positive or negative?
Negative.
Negative. And acceleration is negative. Now, which of these graphs is the velocity becoming more steep?
In 1 and 2.
It's becoming more steep in 1 and 4.
Oh, I meant.
Does everybody see that? The slope is becoming more steep in 1 and 4. So graphs 1 and 4 are speeding up.
It's speeding up, and when they're different, it's slowing down.
Bingo. When velocity and acceleration are in the same direction, it's speeding up. When velocity and acceleration are in opposite directions, it's speeding down. Because if you think about it, if I'm traveling in the positive direction and my velocity is changing positively, I'm going to get faster in the positive direction. But if I'm traveling in the positive direction and my velocity is changing in the negative direction, then I'm going to get slower because they're opposing each other. Does that make sense? So if they're moving together, if they're the same sign, same direction, you're speeding up. If they're in opposite directions, they're slowing down. And I want to point out that that's an important thing to understand. Negative acceleration does not necessarily mean you're slowing down. Oftentimes people say, well, it's decelerating if it has negative acceleration. Physics, we don't really like using the word decelerate because decelerate always means slowing down. All right? But negative acceleration does not always mean that it's slowing down. You can have negative acceleration and still be speeding up. You can have negative acceleration and be slowing down. Saying positive acceleration or negative acceleration is more informational than deceleration. So deceleration just means it's slowing down. Both of these are decelerating. All right, so I don't like the word deceleration. Say either positive or negative and get your point across of what you're trying to talk about. But this is how we interpret distance time graphs. Velocity time graphs, you're not really ever going to have a curve in this class because in order to discuss the change of the slope of a velocity, we have to do calculus. And this is not a calculus-based class, so we're not going to deal with that. So velocity time graphs, you're pretty much always going to have a straight line. And yeah. Are there any questions?